students, welcome to my channel, and today we are going to learn about reflection of light. So this video is about the basic introduction, and reflection of light is simply the bouncing back phenomenon of light. This ray which is falling on the surface is known as the incident ray, and that which is reflected is known as the reflected ray. Let's first draw the normal. Normal is a perpendicular line on the point of incidence. This is the point of incidence. This is 90 degree. The angle between the incident ray and the normal is known as the angle of incidence, and the angle between the reflected ray and the normal is known as the angle of reflection. I, R. I is always equal to R. This is the law of reflection. This was the first law of reflection, and this is the second one, that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This plane, whole plane is same. All lie in the same plane. These are the two laws of reflection. Based on reflection property of light, we can define mirrors. Any surface that reflects much of the incident light, this is called mirror. This is called mirror, whose one surface is polished and other is coated, generally with silver, aluminum, etc. etc. Now, there are three types of mirror: plane mirror and spherical mirror. You will now ask, only there are two types. How three? These are further divided into two: concave and convex. You all know about the plane mirrors. This is the plane mirror, and this is a diagram for plane mirror. This is a very rough diagram, I'm sorry for that. Plane mirror forms the image of the same size as the object. You are quite familiar with that. And it forms the image as behind the object. The distance from mirror of the image and from mirror of the object is same. And this shows a property called lateral inversion. It is simple. When we stand in front of mirror, our left part appears as the right part in the mirror, and our right part appears as the left part in the mirror. This is called lateral inversion, interchange between the left and right parts of the object. This is concave and convex. These are called spherical mirrors. Concave, you can remember it by a cave word. This is a cave-like structure, and hence it is a reflecting part of the mirror. And just opposite to it, convex. The cave part is coated, and the reflected part is the other one, which is bulged outside. Plane mirror always forms a virtual image. What is virtual image? Let us see through example. I am drawing an image of a point formed by a plane mirror. So I am taking two rays. We require two rays to make image. So I am taking this straight one. This case is called normal incidence, because angle of incidence is equal to 0 and angle of reflection is also equal to 0. You know I is equal to R. So it will just retrace its path. Okay, I am taking the second ray. It will just obey the law of reflection, I equal to R, and will get reflected. Now my question is, do the two rays actually meet at a point? You will simply say no. So how are we getting an image? I said that when two rays meet at a point, the second point is called the image of the first point. Then how is the image formed? Now, see it with a case. Here is some person who is looking. Now, what will appear to him? It will appear that these rays are coming from some point here. We are just retracing back the rays, the reflected rays, and we are getting the image of the point here. So, this is called the virtual image. The rays do not actually meet, never. They just appear to meet from the point of view of an observer. This is called the virtual image, and just opposite to it, real image. When rays actually meet, then the point is called the real image. Real image is formed in the case of concave mirror. You can say concave mirror. Convex also form virtual. We are going to discuss about spherical mirrors. Particularly the first one, the concave mirror. So first of all, we have to know all these terms related to the mirror. So first draw a concave mirror. Very rough sketch. So first is what? Pole. What is pole? You know that this is the surface of the mirror. The midpoint of the surface of the mirror. The midpoint, as these two distances are equal, this point is called pole, the midpoint of the surface of mirror. Okay, now the center of curvature. We all know that the spherical mirrors, concave and convex, are cut out or especially extracted from a sphere. This is not a sphere, circle, but you can just imagine sphere is a 3D object. Sphere. So the center of the sphere, there must have been some center of the sphere. Let's say this is the center. This center is known as the center of curvature of the mirror. Okay. Next, principal axis. What is principal axis? The line joining the center of curvature and the pole. This is just CP is what? Principal axis. CP is principal axis. Okay. Aperture. Let's say this point is M and this point is N. What are these points called? These are the extreme points of the spherical mirrors. So the line joining the extreme points, or the distance between the extreme points of a spherical mirror, is known as its aperture. Focal and focal length. Focus and focal length. What is focus and focal length? Okay. You may have burnt a paper in your childhood with the help of lens. We are not going to talk about lens in this video, but they all focus the sun rays which are parallel to a point on paper, and it burnt them. isn't it? So focus. Here is point focus, where all the rays parallel to the principal axis meet after reflection. This is called focus. This point is called focus. And focal length, sorry. You might have guessed by now what is focal length. Just focal length, distance between F and P. This is called the focal length. We are now going to discuss about the relation between the focal length, as you know, the distance between F and P, and the radius of curvature. What is the radius of curvature? Simply, you know the radius of circle. The radius of the sphere from which the given mirror is cut out is known as the radius of curvature. Or you can simply say the distance between C and P is radius of curvature. This total is R. Okay. So what is the relation? What is the relation between F and R? So the relation is F is equal to R by 2. Focal length of a mirror is half the radius. But is it always true? This is the question. It is always true? No. This is only true for mirrors of small apertures, not large apertures. Now that you are familiar with all the terms related to spherical mirror, now let us discuss useful rays for tracing. We know that all rays will get reflected in reflection, but there are some useful rays. Their reflected rays are pre-decided in one manner. Let's see. All the rays parallel to principal axis after reflection will pass through the focus. Just converse of this, all the rays coming on the focus will get parallel to the principal axis after the reflection. Next, let us draw it again, very rough diagram. So this is okay. Now when the ray is falling obliquely, now you don't have to draw the normal to this surface, the pole, the principal axis, principal axis itself behaves as a normal, and you have to just measure this angle and draw this angle. This will be also true. Next, one more. Let us see. Now suppose there is an object, not here, beyond C, okay, object. Now the ray is falling through the center of curvature after reflection will just retrace its path. These are the useful rays which will help you in drawing the ray diagrams. I have discussed about the useful rays for tracing the ray diagrams. Now let us come directly at the ray diagrams of concave mirror. So these are the ray diagrams. Concave mirror, just keep in mind there are only 6 cases. Okay. So first, when the object is at infinity, means we don't know the distance of the object from the mirror. So we are taking two parallel rays, they will both pass through focus and meet at focus, and the image will form at focus. It will almost a point sized image. It is a real image because the rays actually meet. Second case, there is a short trick you can just keep in mind for 1 marks or small questions. When the object is at infinity, image is formed at focus, and when the object is at focus, the image is at infinity. These are just reverse of each other, you can keep in mind like this. Focus, infinity, infinity, focus. Okay, let's see when the object is beyond C or between infinity or C, what you can say. So one ray is taken parallel, which is passed through focus, and the second, which I told you, from center of curvature, which is just retrace its path. You can see there's an arrow that signifies that this is just retracing its path. Where is the image formed? These two rays meet between C and F. So the image is formed between center of curvature and the focus, naming A, B, A dash, B dash. You can see that. Now the third case, when the object is at the center of curvature. Here is also a short trick for remembering that image is just formed below the center of curvature of the same size and real and inverted. Real image is always inverted and virtual image is always erect. Now the fourth case, between center of curvature and focus. One ray is taken parallel, which will pass through focus, and one is taken along the C. This is taken along the C. It will just retrace its path. First the ray is incidence along the C, and it will just reflect back. Both meet at some point beyond C or between infinity and C. Fifth case, that when is object at focus, the image is infinity. These two rays are parallel and are never going to meet. So we are saying at infinity, and whenever they will meet after a long distance, and the image will be highly magnified, large. Now this is only sixth case. This is only the case in which a concave mirror forms a virtual image. The question often comes. Now let us see between focus and pole. When the object is between focus and pole, what is the story? The one ray is taken parallel, which will pass through focus, and other is directed along the C, just like this. Okay, directed along C. These two rays are not parallel and not going to meet. So we are just retracing them back. Now, after retracing them back or producing them back, they meet at a point. This is the image formed behind the mirror. This side is front of mirror, this is behind the mirror. So, this is virtual image because the rays not actually meet. They actually do not meet. They appear to meet. Here is some observer, then they will meet. These are all are the 6 cases of the concave mirror.